Greetings and welcome everyone. Thank you for joining us in today's webinar. My name is Zhenggang Luo, the Special Assistant of AIT Belt and Road Research Center. And I'm the moderator of today's webinar. The AIT Belt and Road Research Center was established in 2019 with a vision to serve as an international hub for collaborative and innovative research for robust economic growth and sustainable development in the Belt and Road region. Since its establishment, we have been participating and collaborating in Belt and Road projects, promoting collaborations with China and other Belt and Road countries, universities, organizations, and also supporting young scholars, students' research and study in the Belt and Road region. Today, we're very happy to jointly deliver the webinar on addressing SDG 6 challenges through government, industry, academia linkage in the Belt and Road region with our colleagues from National Research Council of Thailand, Research Center for Eco-Environmental Science, Chinese Academy of Science, and the CASTWAS Center of Excellence of Water and the Environment. This webinar is meanwhile the first event of the Strengthening Collaboration Network between Thailand and China in the field of environment and sustainable development series. I would like to extend my appreciation to the Ministry of Higher Education, Science, Research and Innovation of Thailand and the Alliance of International Science Organizations are the sponsor of today's event. Just for a little housekeeping before we get started. If you have any questions during this presentation, please type them in the chat box. Our colleagues will bring some of them up into the discussion after the keynote talks. Thank you. Firstly, I would like to invite Dr. Eden Wong, the president of AIT, to deliver his welcome remarks.
Thank you very much for inviting me today to welcome you all, colleagues, ladies and gentlemen. Today's seminar on addressing the SDG 6 challenges through government, industry, and academia linkage in the Belt and Road region is the 5th event of the AIT Belt and Road webinar series, and is also the kickoff event of the Strengthening Collaboration Network between Thailand and China in the field of environment and sustainable development webinar series in collaboration with Thai and Chinese partners. As we all know, clean water and sanitation, SDG 6, is at the very core of sustainable development, critical to the survival of people and the planet. While substantial progress has been made in increasing access to clean drinking water and sanitation, billions of people, mostly in rural areas, still lack these basic services. To reduce the negative environmental impact of the investment along the Belt and Road regions, countries, China launched the Green Belt and Road Initiative. In this regard, so far, great efforts have been initiated by China and the international partners. Thailand, as the chair of Asia-Pacific Economic Cooperation, APEC, in 2022, is facing multiple challenges from the perspectives not only of governance, but also of technology innovation and implementation in order to achieve its national plan on green and sustainable development. These backgrounds provide a great opportunity for Thailand and China to take on the next step in jointly improving their water environment and water resources through an integrated effort of government, academia, and industries. Today, we are delighted to have experts who are deeply engaged in clean water and sanitation SDG 6 issues from governments, academia, and industries. They will share with us their knowledge, experiences, and opinions, aiming to identify the key areas for future collaborations and draft a roadmap for enhancing long-term collaboration in advancing the SDG 6 in both countries and in the region at large. And finally, to seek potential resources to support these collaborations and partnerships. I'm confident that their presentations will help the audience obtain comprehensive and detailed information and knowledge from different professional viewpoints regarding the clean water and sanitation. As a unique regional multicultural institution of higher learning offering state-of-the-art education, research, and training in technology, management, and social development with the motto, social impact with innovation, AIT is well positioned to play a leading role in the sustainable development of the region and its integration into the global economy. AIT is an active participant in the Global Times Higher Education Impact Ranking, which places AIT in the top 200 of universities in contributing to our pursuit of the 17 SDGs. And I also would like you to know that we're working very, very close now to finalizing in collaboration with a major NGO, global NGO, on setting up a new Center for Clean Water and Sanitation on the AIT campus. That will be announced within the next few weeks. I'm confident that AIT's partnership with the Belt and Road Initiative would be mutually beneficial in the pursuit of sustainable development in this region. Finally, I would especially acknowledge the Ministry of Higher Education, Science, Research and Innovation of Thailand and the Alliance of International Science Organizations for their generous sponsorship. I also appreciate our speakers for giving their time and their great support for today's webinar. I wish you all a very successful webinar, and thank you very much.
Thank you very much, Dr. Wong. And next, we are honored to have our opening speaker, Dr. Viparat Deong, to deliver opening remarks. Dr. Deong is Executive Director of National Research Council of Thailand. Now, please invite Dr. Deong.
It gives me great pleasure to deliver opening remarks for the webinar on addressing water and sanitation innovation and challenges through government, industry, academia linkage in the Belt and Road, with an aim at strengthening collaboration between Thailand and China in the field of environment and sustainable development. The National Research Council of Thailand is honored and grateful to be a part of the partnership in organizing their webinar together with the AIT Belt and Road Research Center of the ASEAN Institute of Technology, the Research Center for Eco-Environmental Science of the Chinese Academy of Science, and the Katwa Center of Excellence for Water and Environment. I should mention that NRCT have launched cooperation with the Belt and Road Initiative and is hosting the Digital Belt and Road International Center of Excellence, known as BRRC Bangkok, in which AIT is collaborator through this platform. I'm confident that the Thailand-China cooperation will get stronger in the many years ahead. NRCT is the principal organization in Thailand which guided the development of the country and public policy by using research, including the integration and the administration of national research budget leading up to the country's utilization. NRCT administers research work with professional standards by using moral principles to reach achievement. NRCT employs these values and principles in its delivery of Research and Development Program in alignment with the UN Agenda 2030 and the Sustainable Development Goal. I'm confident that the outcome of this webinar addressing water and sanitation innovation, as well as its subsequent webinar on other important key sustainable development sectors, will be valuable in learning the status of SDG implementation in Thailand, China, and other countries in the region. Again, I thank our partner, organization, and stakeholders, and I wish the webinar well.
Thanks for Dr. Dion. Now we are honored to have our next speaker, Professor Narong Sriratawarangku, who is the President of National Science and Technology Development Agency and Vice President of Alliance of International Science Organizations.
Distinguished guests, ladies and gentlemen, on behalf of Thailand National Science and Technology Development Agency, or NASDA, it is my great honor to deliver opening remarks on this webinar on addressing SDG 6 challenges through government, industry, academia linkage in the Belt and Road, hosted by NASDA outstanding neighbor and dear friend, the Asia Institute of Technology, or AIT. Ladies and gentlemen, Asia is at a crossroads. The region's rapid economic growth has often come with concerns over environmental problems. In this, we are increasingly using resources at the cost of the environment. Many policymakers agree to the necessity to upgrade development paradigm to achieve sustainable growth. Social inclusion and environmental protection must be at the heart of our effort if we are to have long-term sustainable development for all. There are encouraging signs that the region is taking on board the message that we must move toward clean water and sanitation growth. Many emerging economies have started to embark a sustainable development model that make green industry competitive and serve green technology markets. NASDA has been actively working to support Thailand and developing nations in our endeavor toward sustainable development through technological cooperation and policy dialogue. This commitment is to synergy with Thailand's national agenda on the bio-circular green economy, or BCG economy model. I would like to express my appreciation to AIT for leading the implementation of this important project to strengthen collaboration network between Thailand and China in the field of environment and sustainable development. In my capacity as the Vice President of the Alliance of International Science Organizations, or ANSO, I am delighted to see an engagement of such an extreme institute like AIT in ANSO activities. Before concluding my remarks, I would like to thank the organizers and sponsors, namely the AIT Belt and Road Research Center, the National Research Council of Thailand, Research Center for Eco-Environmental Science, Chinese Academy of Sciences, and CAS Tiwa Center of Excellence for Water and Environment for bringing this webinar to fruition, which will lead to the advancement of clean water and sanitation in the Belt and Road region. I wish you all a success session and that the webinar goals are all met with great satisfaction. Thank you.
Thanks for Professor Seller, very cool. Now we're pleased to have our next opening speaker, Professor Jinhua Cao, who is the Executive Director, the Secretariat of the Alliance of International Science Organizations. Prior to his position, he was a Director General, the Bureau of International Cooperation, the Chinese Academy of Science.
Dear respected participants from both sides, and ladies and gentlemen, it really gives me a lot of pleasure to see a few words at the opening of this workshop on behalf of the Alliance of International Science Organizations. Thanks for the kind invitation, and also, I very much appreciate the leadership by AIT and for the workshop. A big congratulations. I say important because that this workshop focuses on fundamental pressing issues facing lots of developing world, and that is to advance UN SDG 6 on clean drinking water and sanitation. I see important as the selected participants from all walks of life will explore means and ways to enhance collaboration and capacity building between China and Thailand and other parts of the countries in Southeast Asia to address these challenges. To address challenges of this magnitude, we do need government, academic, industry partnership and efforts. I anticipate a full exchange of views that will lead to some concrete understandings, and possibly that we can really forge some partnerships. So in this regard, my understanding that China has always gained a good basis experience thanks past 20 years fast development. I mean, perhaps, some affordable, durable, cost-effective innovation technology. I want to stress the Alliance of International Science Organizations is firmly behind today's discussion and potential collaboration resulting from the dialogue. The ANSO Secretary will render its due support and assistance from its program portfolio or toolbox, that we have available, using our influence as international science organization. Will also explore to leverage other resources from China, to collaborate with those on the Thailand side. Please pardon me, if this end up as only empty words, which I don't think it will happen, because ANSO is problem action-oriented organization. So that leads me to a little briefing on ANSO. ANSO we established 3 years ago with the coordination of the Chinese Academy of Sciences and the support of 36 other national Academy of Sciences, universities, research institutes, and international science organizations. Now we have 67 members who are from 48 countries worldwide. The vision of ANSO is really promote advanced UN SDGs and develop the community with a shared future for humankind. With catalyzing, exercising, and support of various concrete programs, actions in science, technology, innovation, capacity building. In brief, we call it STSC. And we also carry out strategic studies, but definitely give more emphasis on concrete actions. A distinction that we emphasize are the funding of the organization. Another unique feature of this international science organization is the ANSO Secretariat is located in China. In so doing, it gives China the advantage and opportunity to provide more support to this international science organization as a big country to advance UN SDGs. The reason that ANSO was founded is twofold. You can understand like that. One was to give more green and sustainable elements to the Belt and Road Initiative. The other was to let international collaboration STSC a bigger role in advancing the shared development that Belt and Road Initiative aims to achieve. To help to achieve our strategic design and objectives, ANSO manages a set of program initiatives, we call them ANSO toolbox and the kind support of the Chinese Academy of Sciences. ANSO is also actively involved in exploring various partnerships with industries and private charitable foundations. For instance, not long ago, we created a clean drinking water, partnership with a NGO. Another aspect ANSO, or you can call them tools, are that we do have 19 themed scientific international networks. For instance, the Industrial Environment Technology Network that is actually coordinated by Professor Yang Mi, from the Institute. And of course, let me give a little touch on the Belt and Road. The goal of this initiative is very much in line with the US SDGs. It gives a specific emphasis on the South and South collaboration for shared benefits and development. Although we do hope that developed economies will be involved. We hope more and more of them will be involved. And so another reason that the Belt and Road Initiative is initiated is that we really hope that we can share some of the Chinese experience in achieving economic development with other parts of the world, including with Thailand and some countries in Southeast Asia. And the Chinese concept of building a community of shared future for humankind really implies interdependence, mutual benefits, win-wins, tolerance development, and sustainable development, and global governance, despite of all the differences in different aspects. So let us work together for a shared future, and I wish the meeting a good one. Thank you.
Next, we are pleased to have our first keynote speaker, Professor Chongrak Poprasert, who is currently Professor of Civil and Environmental Engineering at the Faculty of Engineering, Thammasat University. He received his PhD in Civil and Environmental Engineering under the Fulbright Scholarship from the University of Washington, Seattle. Professor Poprasert has served in the U.S. National Academy of Science panel on productive utilization of waste in the developing countries, and the Water Environment Federation Task Force on Natural System for Wastewater Treatment. He was a recipient of the BRRC Prize for Ecology, Outstanding Scientist Award, and so on. And he is listed in the world's top 2% scientists. He has more than 120 publications and also is a co-author of the book, Organic Waste Recycling, Technology and Management. He was also invited to serve as a visiting professor and scholar at many universities and organizations. Now, we are pleased to invite Professor Poprasert.
Good afternoon, all distinguished participants. Can you hear me?
Yes, Professor,
okay.
Yes.
Yeah, thank you. So it is my honor to share with you presentation about the Sustainable Development Goal, or SDG. SDG number 6 emphasize on clean water and sanitation, and how the linkage among government, industry, economic sector can help to achieve all these SDG 6. The presentation was prepared by our team, Dr. Chawadit Chaiwong, Dr. Kesalin Jinda, and Professor Thamarat Kutatep, all from AIT. So we will briefly talk about what is SDG 6, because all SDG, we know that member countries have to achieve by the year 2030, or 8 years from now. For SDG 6, it's about clean water, drinking water, and sanitation. We will talk about the situation of water sanitation, especially in Thailand, and how the linkage among economic industry and government sector, including international organization, especially Belt and Road Agency, can help to achieve this goal. Well, for SDG 6, briefly, there are 6 targets that all member countries have to achieve for their people. That means safe drinking water for all the people, sanitation safely managed for all the people, and also better water quality for the people, and including also good health hygiene system. And in addition, they also suggest there should be more international cooperation and local participation. I think this webinar really addressed the right targets of the SDG 6. Well, for Thailand, unfortunately, there are some data available. For example, like safe drinking water, Thai people, most of them, 99%, have access to basic water services, mean water for drink, or no, not for drinking, for cleaning, bathing, and washing, and so on. But the quality of safe drinking water is still a big challenge or questionable. With respect to sanitation, again, about 25-26% of Thai people have access to safely managed sanitation. This is also about 99% of Thai people have access to toilet, but having toilet alone not enough, because excreta after flushing have to be properly treated. But for hygiene, 85% of Thai people have access to soap and water. This is a big issue because the 15% that have no access at all to safe water and soap and water can also spread the disease. In terms of water quality, all the wastewater generated in Thailand, only 24%, 25% are safely treated. The rest are discharged improperly into nearby water body and so on. So these are the big challenges that we have to address. Now, yes, it is about clean water. Same as I mentioned, 99% of Thai people have access to only basic water services for bathing, for cleansing, and so on. But the drinking water quality is still a challenge. Tap water in Thailand, although they are claimed to be safe, but most people do not drink directly from tap water. So these are the big issue that we have to address. From the analysis of water sample, we found that about 41% of the tap water is appropriate for drinking consumption, and the rest, about 60%, are contaminated with some pathogens, E. coli, fecal coliform, or other chemicals that need to be further treated. On the right-hand side, even in the rural area, in the hill tribe, most of the water sample were found to be contaminated with fecal coliform, with other pathogenic indicator, meaning drinking water in Thailand need to be improved a lot. This is an urgent issue that we need help. In terms of sanitation, as I mentioned, although 99% of Thai people have access to toilet, but after we defecate, after we flushing our excreta, which means feces and urine, most of our flushing excreta go to on-site system. That is like a cesspool or septic tank. From the survey, we found that about 25% of this wastewater or black water are properly treated, 75% not properly treated. Again, this is an issue that needs urgent action if we want to achieve SDG 6 by the year 2030. I emphasize again, 8 years from now, which is not a long time. Well, again, only 25% of excreta after flushing are safely treated or disposed of either in the properly designed commercial septic tank or in the centralized wastewater treatment system. 75% are not properly treated. As I mentioned, most of the on-site system, well, in Thailand, most household buildings are required to have on-site treatment. So for household, the household they use latrine, like chest pool, or septic tank. Sewer connection may be only 14%, not enough. From our investigation, this is a data about the influent or the excreta after flushing that go to either chest pool or commercial septic tank package. You can see that the influent or excreta contain high pollutant like organic matter, BOD, COD, or the pathogens, which is like fecal coliform or E. coli. Concentration is 10 to the power 9 number per 100 ml, a high number. And now this is a data after treatment by the chest pool or commercial package. We can see that fecal coliform E. coli still very high, 10 to the power 6 number per 100 ml, higher than the standard for disposal. We use BOD, COD also still high. And this is why we need urgent action also to take care of our sanitation problems. So in summary, the on-site system being used in Thailand, septic tank or chest pool, do not work properly due to mainly the short retention time. Septic tank, the size is about 1 to 2 cubic meter. So the excreta stay in the septic tank maybe 1 or 2 days or 3 days, not enough to kill pathogens, not enough to remove the pollutants. And the effluent from septic tank or chest pool is normally discharged into the nearby sewer or canals or river, causing pollution. Well, these are example. Sorry to show you. This is a Bangkok canal, which is quite polluted. When I was young, I used to swim this canal, but now it's not possible, not safe to do so. So again, that's why we need the Belt and Road Initiative to do something also to help us. And beside that, the fecal sludge from the on-site system, because septic tank or chest pool, the fecal sludge accumulate in the tank need to be empty once in 1 year or 3 years and so on. But unfortunately, in Thailand, there are not enough facility to treat the fecal sludge. So 80–90% of them are discharged like this one improperly, not good. So some fecal sludge is dumped into the nearby canals, to the road, open areas, and you can imagine fecal sludge is heavily polluted with pathogens, with organic matter, or the pollutant and chemicals. So it affects the health of the people. For the hygiene, about 85% of Thai people have access to soap and water, but that is not enough because we have to create better awareness of the people how to use soap and water properly. So education is also important to educate Thai people so that their health and well-being can become better. Well, here again, so hand washing facilities are available, but we need to have more awareness and educating how to wash the hand properly to avoid disease transmission and health problem. Well, in addition to our existing problem due to the climate change that's happening now, so there will be more frequent condition of flooding or drought. So this situation also will make our SDG 6 or clean water sanitation situation more challenging to achieve. But we must not give up we must do something. The impact of the unsafe drinking water from the data of Public Health Ministry, there are about 3,800 deaths per year due to unsafe water resources or unsafe drinking water. There are also about 3,000 deaths from no access to hand washing. So as you can imagine, without hand washing, so the disease transmission through food, to drinking water, to touching the mouth, and so on can be quite serious. And for sanitation, the data show that there are about 200 deaths from unsafe sanitation, but the unsafe sanitation can cause other problems like polluting drinking water, polluting hand washing, and so on. So the challenge forward. So I think all of us have to help Thailand or other countries also to provide safe drinking water and also safely manage sanitation. This is a must. That is why cooperation, the linkage among academic, industry, and government are important, and also the international organization. And we also must create awareness for the people that if we drink not safe water, if we have improperly managed sanitation, then you will have health problem and death and so on. For drinking water, of course, Thailand have good basic services, but drinking water is a big challenge. So we must improve, have this safely managed service which is available when needed, accessible on premises in household, and also free from contamination and pathogen. For sanitation, we also must have a proper treatment, either on-site, off-site. The present system of on-site do not work well. And for hygiene services, in addition to soap and water, creating more social awareness, education is also important. So the sector in Thailand, government sector, Ministry of Natural Resource and Environment are important, Public Health Ministry and Interior Ministry. Industry, we have some big industry like SDG, Siam Cement Group, PTT, Petroleum Authority of Thailand, academic, where of course university in Thailand, they are doing research on this aspect also. But importantly, I think international organization, the Belt and Road Initiative and other NGO are also important. So I have some case study of successful linkage that help to improve SDG 6 clean water sanitation. Well, again in Thailand, okay, we have analyzed the sector that has high influence is the cabinet or policy maker. And the sector that have high interest in water sanitation are, of course, the people, the user, like you and me, or NGO, and so on. So to make it successful with high influence, high interest, then the concerned government agency have to come in. So these are examples of the successful case study in case of clean water. Here is a cooperation between industry and government. So industry, the company Drink Well, they have developed the hybrid ion exchange. This is in Bangladesh. As you know, in Bangladesh, groundwater normally contain high concentration of arsenic and fluoride. That people that use groundwater can have sickness due to high arsenic. So this hybrid ion exchange has been developed as the mobile ATM system. It can go anywhere. And now the people in Dhaka are happy because they can have access to this good water and not expensive also. The second case study on sanitation, this is collaboration between the organization and AIT academic. AIT got the support from the Bill Melinda Gates Foundation and ADB Bank to develop solar septic tank, or as I showed you before, conventional septic tank do not work well. So here we utilize solar energy to heat the septic tank. So when septic tank content has high temperature, it can kill the pathogens and also reduce the fecal salad problem. So it worked really well and the system has been applied in Thailand, in Cambodia, and neighboring country with good results. Another case study, this is among industry, organization, academic. Again, the Bill and Melinda Gates Foundation, of course, they have money. So they support AIT to develop the cyclonic toilet, okay? And the system worked really well. Then the Siam Cement Group, the industry, expressed interest. So we contact with them, and they have now developed more commercial and install in public area, working really well. Now for the hygiene, so this one cooperation between industry and organization. In Singapore, the company Watershed, they have developed the portable hand washing facility, which is easy to use and enjoyable. So this machine now, UNICEF has applied them in Cambodia and Vietnam with good results. So the children, the people now have better hand washing facility. So I trust the health of the people will be improved also. This one example of corporate linkage between organization and academic. The EARWAC team, University in Switzerland, got funding from the Bill and Melinda Gates Foundation and developed the hand washing with water recycle. So this one can be used with minimum water, safe water. So this technology has been used in South Africa, Kenya, with good success. And so these are the good results. In terms of water resource management, here in Yom in Thailand, in the province in the north, we have a river. So in the dry season, of course, a farmer do not have water for their irrigation. In the wet season, flooding happen. So with the support from the GIZ, a German organization, then the committee of the river basin has been developed, and they have managed the Yom River very well, minimize the problem during flood and during drought, climate change. So yeah, so finally, I think I try to share some of the successful case study. Thailand, not only Thailand, but other neighboring less developed countries also need to have safe drinking water urgently, and also need to have properly managed sanitation services. So to achieve this one, relevant government agencies, academic, industry, and international organization, especially Belt and Road, have to come in so that the people in Thailand and other countries also can benefit from this cooperation. Thank you very much.
Thank you very much for sharing the current situation of the SDG 6 in Thailand, Professor Russell. Now, we are pleased to have our next keynote speaker, Professor Yuan-Song Wei, who is a director of a laboratory of water pollution control technology, Research Center for Eco-Environmental Science, Chinese Academy of Science, Deputy Director of CASTWAS Center of Excellence for Water and Environment. His research area focuses on wastewater treatment and reuse, organic solid waste treatment and resource recovery, river restoration, and antibiotics resilience pollution control in environment. He published over 350 papers in peer-reviewed journals, including over 150 papers in the international journals, and was awarded by the second prize of State Scientific and Technological Progress Award of China in 2018. Now, please, Professor Wei.
Many thanks. Can you hear me?
Yes, thank you.
Yeah, thank you. So it's my great honor to share our experience for the cooperation. So in the past years, we have very successful cooperation with Sri Lanka on water science and technology. So my topic is related to the China-Sri Lanka cooperation on water science technology from idea to success. I will go this way. See? Sorry, it doesn't work. Sorry. Okay. So I will brief introduce from this way. Okay. So I think it's our cooperation has a long-term cooperation. Nearly 10 years ago, in 2013 August, so there was an email sent from Sri Lanka, the training of the seaway water and sanitation training program, the training. So it was the first time for us to know the CKDU. From this CKDU is related to the drinking water. And since then, and from in 2015, there is a milestone for our cooperation. We signed a MOU between the CAS and the Ministry of Water Supply in Sri Lanka. And in this, based on this MOU, so the CKDU course studies and safe drinking water supply is the key cooperation issue. So, and since 2015, 2016, there's two government level MOU was signed between CAS and the Ministry of Water Supply and the Ministry of Health. So, and in 2016, so, and the China Grant project was approved by both government. And since then, construction from start from 2017 to 2020. So this is the GRD, this is the building was finished construction in 2020. And it also was awarded the best project in Sri Lanka of Ministry of Water Supply. So, and this is just a brief introduce our cooperation from start to the success. So, and so I think for our cooperation, the key issues is the safe drinking water supply and the CKDU. And for our cooperation, so this is there's the first MOU is very important because in this MOU, this is government MOU. So there are 4 cooperation forms established: the GRDC, CKDU control, safe drinking water supply, and education and training program. And we are also, our cooperation was listed in the joint statement between China and Sri Lanka. This is our second milestone. So this joint statement, it means the cornerstone for the country to country, government to government, the cooperation. And so, and based on this, so in the past, from the years, so our cooperation focused on these the 4 parts, the framework. So, and this is solid for our foundation for our cooperation, the joint research, capacity building, and the technology spreading. So we focus on this is the key issue, CKDU core studies and safe drinking water supply. Today, I will introduce our cooperation on drinking water supply. So, and also, so just mentioned, so with our cooperation, so the University of Pennsylvania was become the founder members of UNSO in 2018. This is the Vice Chancellor of UOP. And also, this is the framework. So in the past, we sent many MOUs. Several MOUs are very important for our cooperation, like the first MOU and the MOU with the Ministry of Health, and also MOU the 3 parties with the University of Pennsylvania in 2018. This is our CAS president now. And last 2 years ago, so our MOU was renewed between CAS and the Ministry of Water Supply. So we, based on this, the cooperation, so we both sides try to find the financial support from both countries. And this is from China side. So the biggest is from the China Grant Project, from our government, and also our CAS program. So this is, you can see that it's very, very helpful for our cooperation in the past. And so for the capacity building, there's two ways. One way is for the platform. So this is the building. This is the building. So the GRDC was handed over to the Ministry of Water Supply in March 2021, and also it is in operationalization last October. So this is the mobile water quality analysis. And also for the capacity for the education, human capacity building, education. So since 2015 till now, there are 32 Sri Lanka students studied in CAS, which is the financial support, the annual scholarship, CAS president fellowship. So and till now there are 8 students graduated, including 5 PhD students. And we are also there Pi-5 fellowship for the advanced senior scientists from Sri Lanka. So from 2021 and 2022, there are 4 distinguished scientists from University of Pennsylvania are awarded the Pi-5 fellowship. So for this, we also do the training for the water professional and nephrology and the public health professional. So we cooperate with the Beijing Peking University First Hospital and also Beijing CDC for this training. Okay. So now I will for our joint research. So for the drinking water, for the drinking, because the CKDU is happened in the North Central province. So we would like to know what is the problem. We should know the water quality, water quantity, and the water supply, the situation. Based on this diagnosis, we know the key issue, and then we develop suitable and cost-effective technologies for Sri Lanka. And this is cost-effective, custom-tailored technology like the EDR and the nanofiltration. And based on this, based on this development, we do the demonstration. And for the centralized water supply, we use the EDR. For the decentralized drinking water treatment, for the nanofiltration. Based on this demonstration, we can provide a solution for the safe drinking water for the water for all of Sri Lanka government. This is our roadmap and the research purpose. And for example, for the water quality analysis, so in the past, we carried out the field investigation in the North Central province. We found the dissolved organic matter in groundwater, so it's a little bit higher than the drinking water standard. This is the finding is very helpful for us to develop water treatment technology. And also, we also cooperate with Sri Lanka partner and make the groundwater quality field investigation in the North Central province, in the Annapurna and Bonanwa, in the wet season and the dry season. do the field investigation for we know make the groundwater quality atlas, because in Sri Lanka the water supply is also not as good. For example, the roughly 50 is supplied by the pipeball, most from the groundwater. So if we know the water quality, the situation, it is very helpful for local people and local government to develop a water supply and program. So we can see from this water quality atlas, we can see where the problem. Based on this, we also do some field investigation for the existing RO drinking water stations in the North Central Province. We found the majority RO drinking water stations showed excellent salt rejection rate, but the average water recovery is very low, and the removancy for hardness granite also very high, but so ions also can very good can be removed, but there's a big concern for the low recovery of rates of water and membrane falling, and also the not professional operation maintenance are also a big issue for the drinking water station. So, and for that, if we know this, we know the field investigation, we know this is the situation, then we should want to do some demonstration and in Sri Lanka. So how to that? We need to work together with the water industry. So with the financial support, the ANSO. So we have ANSO Environment Technology and Industry Alliance, and these alliance, their visions is cooperation with the Chinese government and the company, university, and research institution, and the cooperation with the Foreign Institute International Organization, and the cooperation with the related to department, company, Belt and Road countries. For this, the cooperation, for example, they can help us to the forum workshop, international exchange training, industry training, and industrial cooperation, and also make the national industrial standard like this. Based on this, the alliance, we have very close cooperation with several water companies for the groundwater treatment technology demonstration, like the EDR, so and the nanofiltration and defluoridization. All these three demonstration projects are very successful. They were carried out since 2017, 2018, and 19. So, and we are also very happy. So, the Sri Lanka National Water Supply the Drainage Board also give us the letter. Thanks for our work for this technology. So, based on this demonstration, so we also continue the cooperation with Sri Lanka. For example, Sri Lanka think the EDR technology is very suitable for the groundwater treatment. So, and now we are discussing to set up the joint venture of the EDR. So we are also, you know, the Sri Lanka is an island country, is the tropical area. So rainwater is rainwater harvesting is very important. So we also cooperate with the company to develop technology, rainwater harvesting for the portable use, especially for the rural area. So this is we collect the roof rainwater and then treat, and then for the drinking water. So we can use this roof rainwater for the drinking water for the school and temple, church. And also, you know, for the rainwater is also very useful for the irrigation. We also develop the rainwater harvesting technology for the irrigation, like the golf course and the agricultural station and the two public areas. This is demonstration were carried out in Annapurna and Twinkle Valley. And we also do the joint work together for the academic events like IWA, WDCE 2019. It was happened in Colombo. We joined together, and also before, for example, in 2018, Ms. Tinina visited our institute and to discuss to how an IWA, the WDCE. So we are very happy to help them to get this is the big event in Colombo. And also, you know, in 2010, there was the COVID-19 pandemic. So, and we are also organized together with the airlines to make a donation for Sri Lanka side for fighting the COVID-19. And for example, we also, our company partner also donate some the water quality analysis instrument. So in 2020, and also the PCR donation to hospital improve the test capacity. So at the same time, we also make some training in 2020 for the technical support assistance Sri Lanka fight for the COVID-19. Okay. And so I will brief make summarization of our cooperation. So and in the past, so our cooperation already become a flagship project of science and technology cooperation through government, industry, and academia between China and Sri Lanka. So I'm into providing the safe drinking water and tackling CKDU. We are also develop a very novel, successful cooperation model, and also long-term and comprehensive cooperation. So, and the capacity of water treatment research in Sri Lanka through the cooperation is also greatly improved. So, and so that is our summary. So I hope we are also in the future we can enhance the cooperation with the Thailand AIT. So in 2019, so we visited the AIT, and the AIT, the Dr. Eden Yung also visited our institute and to sign the MOU. So, and now we also have a cooperation project with AIT for the sanitation. So, and it will be finished in the next year. So, and this is our future action plan for the cooperation with Sri Lanka. This is GRDC operation and management, joint operation and management, and the research and the technology, like the CKDU was that safe water supply to support water for all of Sri Lanka, and also consider wastewater treatment technology. And we are still continue the education and the training and the exchanging visiting. So, and now Sri Lanka, there has a very big target for water for all. And so we hope we can work together to make the dream it comes true. Yeah. And thanks all. That's all. Thanks.
Thank you, Professor Wei, for sharing us this project in Sri Lanka. And next, we are pleased to ask our next keynote speaker, Professor Gang Liu, who is a team leader at Research Center for Eco-Environmental Sciences, CAS, visiting professor at Delft University of Technology, Deputy Director of CASK Lab of Drinking Water Science and Technology, Chief Editor of IWA flagship journal Water Science and Technology, Editorial Board Member for Engineering, National Science Review, and so on. Research focuses on nature-based water purification, carbon neutral water systems, drinking water biosafety, and biological stability. Now, please, Professor Liu.
Thanks a lot for the introduction. It's the stream smooth? Can you hear me?
Yes, we can hear you.
Okay, yeah, then I will continue. Thanks a lot for the invitation and for the introduction. It is really a great honor, and I'm very pleased to have this opportunity talking about the SDG 6. After discussing with Professor Wei, I received this mission to talk about drinking water specifically, so SDG 6.1. I hope I'm not too negative. I think we have made great progress on SDG 6.1 on drinking water, called Safely Managed Drinking Water Service. And after hearing the presentation of our first keynote speaker, Professor Paul Russert, I found that in Thailand, we have also made a great progress toward achieving the SDG 6.1. Well, in today's presentation, I'd like to share 3 parts of my work and the general progress till now, so the global overview, and introduce the CV, so the Center of Excellence on Water Environment, and also part of the work that ANSO is supporting us. And in the end, I'd like to give some vision on how we may accelerate the process of achieving the SDG 6. Well, if we talk about the safely managed drinking water service by 2020, and this is a map from UN Water that is summarizing the global updates. So we see the light blue and dark blue part is the part that doing very well. And in general, the number is quite promising. They say about 74% has achieved the safely managed, or at least the basic drinking water service. Well, if we have the focus on the at least basic service, then the data shows at least 84 countries has achieved the universal access, which means it's more than 99% has been achieved the universal service of basic drinking water. Meanwhile, we can see still there are parts with yellow and brown marked on the map, which we still have a long way to go. And I'd like to map this with our the Belt and Road Initiative map. So if I go back and forward, you can see that our Belt and Road Initiative is covering the lower development parts very well, which means we can have this really a big contribution to combine the Belt and Road Initiative with the water science and technology to push the final part and realize the SDG 6, especially 6.1. If we look into the over time, the development, as see in the first keynote presentation, we have achieved quite a progress in Thailand regarding the drinking water service. And globally, so we see from 2015 till 2020, within the 5 years time, in general, we have 4% increase on the safely managed drinking water service, and then the decrease of the limited, unimproved, and surface water. Well, if we look into the population and the service that is covered, that somehow that there are about 2 billion people is improved and covered by drinking water service with safely managed technology. Well, when the population increased and we see in general the whole situation improved significantly. Well, while it's not the global and universal thing, when we look into South Africa, and there are especially the low development and least development areas, the coverage rate is still low, while the European and North America, they have the highest coverage, and Australia and New Zealand, they achieve 100% coverage. But the Sahara Africa is facing quite a big challenge, and the Central and South Asia is still, I think in general, the safely managed percentage over 60, while the basic and other limited service is still somewhere 40%. The data is positive. So globally, we have 74% coverage and improvements. Well, when we look into the detailed data on the quality part, so not only the service coverage, but also how good the quality is and how safe the water is when we measure the E. coli. So here are 4 examples. So the countries we look into specifically, you see in the light blue is the improved, which is a better managed and treated drinking water and the better quality of water supply that we can expect. Well, you see Congo, Ghana, and Nepal and Bangladesh. So here, the improved service covered around 90%, and Congo reached 96%. But we have become a little more negative when we look into the E. coli detection, because you see directly no E. coli detection water has a much lower rate than the improved service when we look into the overall population. So, which means that although the drinking water is supplied and safely managed, but the contamination may still occur. Well, I see in the first keynote presentation that in Thailand, the detection of E. coli in the managed or improved drinking water can be up to 8.73%, which means similar things is occurring here and there. Well, when we look more to the detail at Newport, then this is the data shows. So we have in the blue line, it's a line showing the detection of E. coli, and in the right line is more serious as we look into the active. So the alive E. coli. So the detection rate and the active rate, intact cell, and possibly the more active activity of the microbes. And we see that the percentage is still rather high, up to 20%. So which means make me have this title of this slide. So yes, there's great improvements, but still it might be neither safe nor enough. So we have improvements, and we invest a lot, and we see clearly the progress. Well, there's still more attention should be paid to the exactly the quality. So not only the clean, transparent water, but also it should be well safe. Another concern comes from the resilience of the system. So we build something globally, and we want to achieve the universal and clean and safe drinking water service. On one hand, there might be contamination and quality risk. On the other hand, it might be very weak when we are experiencing the shocks like a pandemic. And this is a survey. It's also from UN Water, and it's done by SMS to the customer, and then to survey them if they have a significant disruption on their drinking water service. We see the number is quite high, and meanwhile, we see at some place the rural area has a higher interruption, and some place there the city has a higher interruption, which means in those countries, especially in Africa, the system developed there it's not resilient enough. So it's supplying good service maybe, but during the pandemic there is quite a big and high attention should be given to those systems during the special period. So come back to the theme of this webinar and workshop. I think we can pay attention to what we can do with the policy, industry, education, and research. So the research should have something that is easy and simple and work, and then to be resilient during the different periods. And then the education is another very important part that to help the capability and then also the professionals to run those systems. And the industry should have a system that can be workable to different situations in different countries, and then along with the workable policies. I think there's still distance to go to have this really the SDG achieved globally. And then now I'm going to move to the second part to introduce the CV Institute and part of our work together with the support of ANSO. CV was established in 2013, and as Professor Wei has introduced, quite a lot of the activities we are doing with Sri Lanka is a very good example, but we are also working with Iran and other countries in Asia, in Africa. It's quite a big network. We are focusing on the education center is incubating the professionals. So make sure that the system we build or they build there has a good operator, and it's guaranteeing the system is performing well. And meanwhile, the CV and ANSO is also a platform that is promoting the joint research and international cooperation. So we are establishing the joint research center, and we are also going for international projects together. And this, as I mentioned, this is a network that we are exchange our knowledge and experiences, so that the experience, the technology, and all the scientific outcomes can be benefits to all our partners. And if we look back into the Belt and Road Initiative, this can really give a good and big contribution to solve the local problems. If we focus on drinking water specifically from source to tap, this is our Institute of RCES and CV is all covering those parts. So we are working from source to tap to guarantee a high and good quality of drinking water, health and safe. And if to divide it into detail, then we have source water management and remediation, water purification materials and technologies, and leak detection and facility management for the drinking water pipelines. And we have risk assessment, water quality management, and standard siting as well. And you see the pictures are some examples we have, like the early warning system, the wetlands for source water management and leak detection. And arsenic removing is a very natural technology in our institute. And as mentioned in the first keynote, the arsenic contamination is, has a high health risk. If we look into the water system, so this is a bit I think the slides is mixing together. If we look into the water system from source to tap, one of the source water problem is algae problem, so algae bloom that can have toxic effects to the water, and also it will has a negative influence on the treatment performance. And what we have been doing on drinking water source, one part is focusing on the algae problem. And so this is an example that we have developed based on the monitoring and big data, and to have this platform to predict the algae in reservoirs. So here it's in the platform now is in Chinese. So on the top, you see the monitoring of different algae, the real-time data. And on the left bottom, you see the temporal and spatial variation of those algae in a specific reservoir. And meanwhile, based on the big data, we can have a prediction for the coming 7 days, which is going to be the dominant algae in the reservoir water. And then if the algae, the dominant algae is problematic, then actions can be taken in advance to manage it. One of the examples for the management and the restoration is that we are aiming for neutral or close to neutral and in situ technology. This is one example that we to disturb the sediments and then create a high turbidity water on the top, and then this can stop part of the light going through the water, and then the algae problem can be prevented, or the water can be restored. So besides the source water management, for water purification, we are also looking into the nature-based and simple managed and high efficient technology. One example is the riverbank filtration. So from the river to the abstraction well, then the aquifer can do a very good job on purification. So if the retention time can be around 60 to 120 days, then the pathogen can be very well and completely removed. So the water can be well safe. One example is that we have done this work in one of the river area in China, and along the river from the upstream to downstream, we select 6 locations, and then the river water is recharged into the well water in the villages where the people in the village is using the well water directly for their daily life, drinking, washing, those activities. So if we look into what the nature can do, so without further treatment, only the recharge of surface water from purified by the aquifer. So if we look into now the very hot topic of nanoplastics, we can remove it very well. So from 0.29 microgram per liter to 0.05 microgram per liter in the groundwater well. So it's very highly efficient, purified by the neutral-based aquifer. And if we look into the virus, so now we are experiencing the pandemic, but water virus is also one of the concerns. So if we look into the virus, then you see this on the right, right in the blue area. This is the groundwater, and the other part is the surface water, which means the aquifer can purify the virus very well as well. And if we look into the PFAS, so the different types of PFAS, then we see the surface water, we have a high amount of PFOA and also some other PFAS. And if we look into the groundwater, so focus on the PFOA, then it is very well removed as well. So basically, by this neutral process, nothing else has been done. We can purify the water very well. Basically, on the standard of what we mentioned in the SDG 6, it's safely managed, and aiming for future for the emerging contaminants, it can also be well controlled. This is some work that we are building in the Netherlands, and meanwhile also developing in China. We call it one-step RO, which is combining the aquifer treatment with one-step membrane filtration. It can be reverse osmosis, nanofiltration, ultrafiltration. It can also even be sun filtration to be combined with. Then we see a very clear benefits of this, because it is nature-based technology, and then it's chemical-free or almost chemical-free. And there's no necessary for the chlorine or other disinfectants to kill the bacteria. Then the toxicity and even the CO2 footprint is much lower. So we are now thinking that this can be a perfect solution, even in the low developed areas. Like in Africa, there, I think even the high-tech water treatment system might be difficult to operate because of the capacity. And we have this published in the engineering, so the Journal of Chinese Academy of Engineering. Well, for drinking water distribution system, for this part, I will go very briefly and just to be complete in drinking water supply system, because the water we produce may, the quality of the water we produce may deteriorate during the distribution. You see those pictures. And some occasions, the discolored water from the tap. And together with Lihe, we are upgrading of our monitoring system and to have an online sampling and monitoring of water at customer tap. And you see clearly that the peak hours and the peak load of particles and bacteria can be captured and analyzed and source-checked to see where they're coming from. And this is an illustration to see in the morning and evening, and then we have a higher load of particles, bacteria, and also we can see that those higher load is coming from the biofilm and loose deposits in the distribution pipe. And this is some development of online technology. So we see the new nanopore sequencing, and this can be combined with our new device, and it's going to be used in Beijing and already upgraded to the new generation. And the treated water with the one-step RO riverbank filtrated membrane filtration system, we see the total biomass, the growth potential, and also the community is all controlled very well, which is giving advanced advantages for the high-quality drinking water. So summing up, and my conclusion is that we have made great progress globally on SDG 6.1. Well, I think there's still distance to go, and this will be covered by, in the future, neutral and simple solutions. And now we have demonstrated that can work very well here in China. And then in the future, with the CV and ANSO support, there's a possibility we can share those achievements to the Belt and Road countries together. And in the end, to achieve the SDG 6.1 globally. Thanks a lot for your attention. That's all for my talk today.
Thank you very much, Professor Liu, for your sharing from a global perspective. And next, we are pleased to have our next keynote speaker, Dr. Chaiwei Wancharongrang, who is a director of domestic wastewater subdivision of Water Quality Management Division from Pollution Control Department of Thailand. Dr. Wancharongrang received a PhD on biomechanics from the University of Texas at Austin, USA. He is also editor of an environmental newsletter, part-time lecturer in many universities, and independent consultant on environmental regulations. Dr. Wancharongrang received the Outstanding Civil Service Award in the year of 2020 and received a scholarship from JICA, Government of Singapore, and Royal Thailand Government. Now, please, Dr. Wancharongrang. Sorry, we cannot hear you.
Okay, can you hear me?
Yes, yes,
Okay.
thank you very much. Thank
Sorry,
you.
yeah. Okay, my name is Shayawi from Pollution Control Department. Probably my talk is going to be about challenge and opportunity in wastewater management in Thailand. Unfortunately, Pollution Control Department is not responsible for all of the index in the SDG, but the one that we are actually responsible is the one about wastewater. So, and that is the topic that I'm going to talk about today. Presentation topic for today is about statistics on water quality and wastewater in Thailand, and the current constraint and challenge and opportunity. The third one will be about opportunity. The first part is about statistics on water quality and wastewater in Thailand. As you can see here, one of the duty of the Pollution Control Department Thailand is about monitoring of the water quality all over the country. And as you can see that we actually make like a map displaying the quality of the water on yearly basis, and the color of the river showing the quality of the river starting from like excellent, good, fair, poor, and very poor. And as you can see now, is that in Thailand it's really difficult to find like the blue line, which is because it's already disappeared from the system, because as you can see in the trend graph on the right side, it can see that like it only appear in some of the year, and the trend is that majority of the quality of the water in the river is actually at fair condition. The reason for the water quality at fair condition is that most of the parameter that we monitor, we found that coliform bacteria is the majority of the problem. When we look at the quality of the coastal seawater, is actually the trend is very similar. The stars actually in here is actually showed where our coastal seawater quality is at a very good condition, and it's very difficult to find a spot where the water quality is at good condition. Only some of the popular tourist spot, and we are really worried because for Thailand, actually a lot of people coming here for like staying in nearby our sea, and then the water quality is not that good. So we actually trying to do like a 20-year water quality management plan, which target that from in 10 years from the beginning of the plan, that all of the water resource will be back to the standard that is supposed to be. But unfortunately, after 3 years of COVID situation, the data is not like the water quality is not improved so much. That because of we have to like a lot of activity in water quality management is stopped. So let's look at the situation right now. Amount of water pollution. Right now, we actually have like about 9.6 million cubic meter per day of domestic wastewater generated. And if you count with like tourists that come to Thailand a lot, that is another 5 million cubic meter per day. So it's almost like we have like 14.5 million cubic meter per day. And we have another 10 million, around 10 million cubic meter per day for wastewater from industry, and about 5 million cubic meter per day from wastewater from agricultural sector, which is mainly from pig farm and aquaculture. So for Thailand, the environmental regulation is really fragmented. We have so many acts that we can use to work with environmental problem, including Environmental Act, Building Control Act, Public Health, maintenance of the and cleanliness and orderliness of the country, Factory Acts, and Industrial Estates Authority of Thailand Act. From wastewater that we have, if you look at this chart, you will see that we have about 14.5 million cubic meter per day of the wastewater, but we for in 1995 we have just only 2 central wastewater treatment plant. Right now we only have 118 wastewater treatment plant that has only capacity of about 3 million cubic meter per day, and that 3 million cubic meter per day is from 98 plant that operating. So it means that we have a lot of wastewater treatment plant that we built, but it cannot operate. The sad thing is that out of that 118 plant is actually distributed to about 90 something local administrative organization. When we in Thailand we have 7,700 city or local administrative organization, which means that only 1% of the city that we have is actually have central wastewater treatment plant, and we already invest a lot. We already invest about $2 billion US dollar into building the wastewater treatment plant, but as you can see that there's a lot of problem that we can build but cannot finish and build and it's not fully operate. The next thing is that when we actually build the wastewater treatment plant, majority of the technology that local governments choose is a stabilization pond, which is maybe the simplest way of to treat the water, just to keep water inside the pond, because they think that the technology is really, it costs them less to run wastewater treatment plant if they have to have one. Then they want to have one that is really cheap to operate. So majority of the local government decide to use just the only stabilization pond, and that's cost only 26% of the wastewater generate is actually handled. And if we count for on-site treatment plant, it's only 74% of the wastewater generated is partially handled by the wastewater treatment system. When we look at the situation of fecal sludge management, that maybe the first keynote speaker is talking about, majority of the on-site treatment system require sludge emptying and transportation. And if you already showed that much, some of the sludge that we transport is actually go back to the environment, is not going to treat properly. We already set up a lot of standard, but the standard that we set has a lot of problem. We already set real estate effluent standard. We already set building effluent standard. Set up wastewater treatment free and central wastewater treatment plant. The problems about the regulation that we set is there's a lot of problem with the regulation that we already set. For example, for wastewater treatment fee, we already set the recommended fee for local authority, but they don't actually want to collect the fee. So majority of the wastewater treatment plant that we are running has a lot is actually subsidized by the local government. Sometimes when they don't have money, they just stop the operation of the wastewater treatment plant. Another one is that we actually set the standard for industrial standard for commercial package system that should be installed in household or in the building, but because of the standard we set require a lot of testing. So we can say that right now all the manufacturer of the commercial package system is still testing their treatment system, and we still have no the treatment system that actually certified with the standard. So this is the situation for household and large building. For household, the majority of the wastewater that is generated for black water is going through on-site treatment system, and gray water in some situation is actually passed to the environment. And for household, situation is the same. For large building, the black water and gray water is actually flow into the wastewater treatment plant before going to the environment. I will just give this slide because it show the same situation. Another problem is that our city still use many of the wastewater management system. Many of the city use the central wastewater treatment plant in mixing of the cluster wastewater treatment plant and mixing with the on-site treatment system. But majority of the cities still recommend their people to use on-site treatment system. The problem with our wastewater collection system is that most of the sewer system in Thailand are combined system, and because of what we are using is the combined system. In many of the time, when sewer regulator or CSO has some problem, it's actually the wastewater is actually bypassed to the environment. And in many of the situation, the CSO is actually very poorly designed. When the water level in the river is very high, it cause the water in the river sometimes it's actually flow back to the system and flow to the wastewater treatment plant. So sometimes majority in some of the situation, the wastewater treatment plant is actually treating the river water. So I will sum up the constraint and challenge that we are having right now. The first one is that majority of the community and the people are unaware of the wastewater pollution problem, especially the common people, that they don't actually aware that their house supposed to have like a wastewater treatment plant, or on-site farmer and owner of the pig farm and aquaculture. They don't think that what they are doing is creating pollution. The second thing is the lack of the wastewater treatment plant for many of the city. When many of the city priority is to build their city, majority of them are prioritized on trying to build a better road, make a better building, electricity system, and wastewater management is probably lower in their list, in their priority. NIMBY or not in my backyard is still a lot has a mentality of the majority of the people. Majority of the wastewater treatment plant, I mean, out of the number that I showed you before, some of the wastewater treatment plant that we have built cannot be operated because of the people nearby neighbor is not, they don't want to have the wastewater treatment plant to run because they don't like to see like wastewater in the tank in their neighborhood, in their backyard. So they just, when the wastewater treatment plant construction is almost finished, sometime the people protest and then stop construction of the wastewater treatment plant, and we cannot local government cannot continue the project. Another one is the local administration organization are incapable, sometimes inadequate to do the wastewater management. In many of the local government, because we have so many, in many of the local government, they don't even have like environmental officer, so they don't know anything about wastewater management. Next is technical constraint, as presented by the first speaker. The most on-site domestic wastewater treatment plant are cesspool, which means that it's actually always leak to the environment or have very low efficiency. And the problem is that for regulation, that we are not required anyone to check the efficiency or inspection of this on-site wastewater treatment plant. Another problem is that wastewater treatment plant operation that always has a lot of problem. As I told you that many of the local government has the budget problem. So if they run out of budget, they just stop running the wastewater treatment plant. Sometimes it's technical problem. It's broken and they don't know how to fix it. And sometimes it's personal problem. So personal problem means that majority of the government officers, sometimes they maybe get promoted and move to another local government, and then suddenly this local government has no one to operate their wastewater treatment plant. Another problem is that operation and construction of combined sewer and make it sending wastewater treatment plant is a huge challenge because sometimes, like as I told before, in the CSO system, sometimes the flap gate in the CSO system is not working, and maybe most of the time the wastewater is actually leak into the water into the river. And sometimes it's actually sealed shut just because of the flooding, and that makes it really difficult to fix. Another one is the construction of the unsuitable treatment plant. We can see a lot of this problem in Thailand. Sometimes the wastewater treatment plant is designed too large, and sometimes it's designed too small, and sometimes it's designed at unsuitable location. It's very difficult when the treatment plant is located in unsuitable location because it requires a lot of energy to transfer the wastewater to the treatment plant. We have regulation constraint now. There's because of the mentality of the general public, it's very difficult to collect the wastewater treatment fee. Although we actually recommend collection of the wastewater treatment fee, but majority of the local governments still don't want to collect it because they feel that it's gonna put burden into a lot of people, and they don't want to lose the confidence of the general public, especially in the COVID situation. Another one is no requirement to for building inspection after construction. For Thailand regulation, after construction of the building or before construction of the building, or the plan actually the plan actually have to send to the government to approve if they put in like proper wastewater treatment plant on site, but when they actually finish the construction, no one is required to go back to inspect if they actually construct the treatment plant according to the plan that they provide to the government. Another problem is that effluent standards are not suitable in many cases. We can see that for Thailand, we set a standard for effluent from the market for textile industry for the power plant, but these three of the pollution source still has a lot of problem complying with our standard. Another constraint is that not enough enforcement for pollution source. The thing is that we actually have so few number of the people, and in every year we actually can inspect, like pollution control department can inspect maybe only probably close to 1,000 building in our country, but probably we have like 500,000 of the building in our country, so it's a little bit difficult to do it like manually. So we have to find another way to do better inspection. So opportunity for research is as what I can think of right now is that probably the thing that I can recommend is that maybe we have to think about a little bit better suitable effluent standard for specific pollution source. Another one is that wastewater treatment plant configuration that is more friendly to the public, to the community, and also use less energy. Right now we are trying to design a newer version of the wastewater treatment plant to be like underground with a treatment plant with on top has like a landscaping, and it's getting better reception from the general public, but I'm not sure that but it's actually use a lot of energy because everything has to be done underground. Another one is like high performance and low maintenance of the on-site wastewater treatment system. Right now, our on-site treatment system is really simple. Like majority of them are cesspool, and we actually set already an industrial standard for that. But there's actually no product in the market yet, so we have to accelerate certification of the on-site treatment system, and probably we should find that, like support the manufacturer to build a better, a higher performance, so that people when we enforce, so that a higher performance treatment system can be installed in the household or in the new building that we are built. Another one is better emission factor, design factor, and course of practice. We has a lot of problem using emission factor from other country, and we have learned that sometimes we when use emission factor from other country, we build our wastewater treatment plant too big or too small. And probably research is should be ongoing about what is the good design factor for our wastewater treatment plant without using the number from other country. Another one is that a better and more suitable way to collect wastewater treatment fee, because right now, as I told you, that a majority of the local government, they don't want to collect wastewater treatment fee, and we are still finding a good way to set up the or to persuade people to pay for wastewater treatment fee. IT system that can be help managing sewer system, that which is a lot of the problem in many of the local government, that they finish building the wastewater collection system, but sometimes, or sewer system, but sometimes they has a lot of problem managing the sewer system, and it allowed sometimes it's a problem of the flooding, sometimes when water get into the sewer system, and sometimes the wastewater leak to the river. The better way of enforcing, we are thinking about what should be the better way of enforcing. Probably maybe installation of the sensor system to help the government into enforcing many of the building that should be complying with the standard. The last one is probably a suitable way and better structure of wastewater treatment fee that we are thinking about. So that is all for my presentation. Majority of it is complaining. I'm sorry about that, because we have a lot of problems. So I really want to show you in order to understand what is the challenge that we have.
Thank you very much, Dr. Wancharongrang, for sharing the technology details, the constraints, as well as research recommendations. Now we are pleased to have our last keynote speaker, Dr. Hai Chen, who is the Chief Operating Officer of Heshi Environment Company Ltd, which is a legend company in sewage treatment equipment of China, and it's a full-line products over sewage treatment for family, household, village, and town and city. Now, Dr. Chen, please.
It's my great honor to share the key learnings and some experience from a company side based on the more than 1,000 real projects we handled in China rural area. So can everyone see my PPT? I have shared my screen.
Yes, but please, can you do the full screen?
Okay. It's okay?
It's not still full. It's not, now it's okay. Thank you.
Okay. So here is my key contents of my PPT. The first one is the current situation in China rural sewage treatment situation, and the second is the solution and the technology for China rural area. And the last one is the change and future. Here I start from the current situation. One was from the China government is right. We should the rural residential environment improvement actions is a big topic for the 13th five-year plan. It including integration of the urban and rural development and the development of social and undertaking in rural areas, and the urban public service extended to rural areas. The key, this is based on the fact, right? Under 31% spring drain and wastewater treatment rate in China current rural area. And then you can see the sewage disposal rate by 2020. In China, sewage disposal rate in city is above 90%, with county around 90%, but town and village is under 30%. So I count here. And the current situation for population control in rural area in China, it's needs for toilet revolution for decentralized wastewater systems. The first is to satisfy the demand of public health and various water quality growth. And the second is economic sustainability of processing technologies. And the third is operation simple and easy routine management. This is a key requirement for the rural area sewage treatment. And in the past 5 to 10 years, we do the projects in China. We faced that the key is China have a very big scale, over 50,000 towns and 2.5 million villages, and over 0.67 billion populations in rural area. But by 2020, there is still lower than 30% sewage treatment in rural area. So it's a big market and a big task for China for rural area. You know, even only for the toilet revolution, the China government has invested over 16 billion RMB for this single project. And but for the inflow quality and between city and the town village, there is no big difference for the key characters. The key characters for rural sewage we faced in China market is a huge scale of spot with which I have mentioned before, and the second is sewage quality and volume unstable. You know, a lot in China population change by season, and the key sewage combined with the toilet, kitchen, bathroom, and the laundry, and sometimes with the rain together. And for the water characters, the components is very complex, high TN and TP. And the last one is we face the key challenge for lack of effective technology and equipment for rural areas. So the key challenge for rural sewage treatment we faced, even for the government, is a high investment, a huge scale, and lack of local management and money for daily operation. So in many areas of China rural areas, we can invest for the equipment, but no money for the daily operation. So the key issue for the local government for rural area is lack of influent water standard, because we have a lot of standard in China. government, the national standard, city standard, and every province have their own standard. And the second is lack of low-cost technology to suit the local conditions. We think the technology should be effective based on the local conditions. And the third one is the lack of equipment certification system from government. There are more than 10,000 equipment supplier in China, but we have no certification system from the China government. And the last one is lack of daily operation and management system. So we can invest for the equipment, but nobody for daily operation. So we just put the equipment there, but no long-term usage. So current China model, we have mainly have three models in China. The single-family household model and the single town village. And the third one is concentration with pipe network. So sometimes we may combine the three models together with different equipment group. So the three model need three different series of equipment. The equipment now currently in China, we have three main different technology. So in China rural survey, the first one is the technology based on secondary biochemical treatment, such as AO, A2O, SBR, and BR. And the second is bio plus ecological combination technologies. And the third one is resource processing technologies. Each technology has their key characters and their occasions. Sometimes we need to find the real effective technical ways based on the real situation. To do this, need some professional people to do the evaluation job first before operation. And as I mentioned, each choice of the rural technologies have their advantage and their characters. Which one is suitable for the rural area is based on the real situation and evaluated by the some professional people. And this is what we think is a trend and a future for China rural area. You can see, as I mentioned, the key challenges and the issues for rural area. We think for the future, we need to do three key kind of jobs. The first one is down the coast. This means we need a reasonable selection of the sewage treatment process technology with low construction and operation cost. For China have a very huge scale. If we cannot down the cost, we cannot up the discharge rate. And the second is for easy management. So this means high degree of automation and simple management, low maintenance, low operation management, and technical requirement. That means this sewage treatment equipment should be very friendship for even local people, easy use. And the third one is optimization of the technology. We really think the sewage treatment technology is very high technology, but we need to do some optimization jobs for different technology. So adopt a mature, reliable, and stable treatment process. And also, we need to make the equipment to be good environmental friendship, low energy consumption, easy to operate. That's the key requirement for rural sewage treatment equipment. And that means we need to standardize our products. We need to make all the sewage treatment equipment to be products, and also made the products standard. That means why is because only the first one is because only standardized products can meet the needs of village and conservative treated markets, because every consumer from village and town do know what they need for their rural areas. And the second is only standard products can allow our users to choose and judge, evaluate the product is good or not. And the third one is only standard products can meet the quality assurance and operation management of a decentralized large-scale usage, because every user can use the same guidebook for daily operation. No need to operate every equipment based on the single usage. So here I want to share some of our thinking and experience in China market. We have standardized all our product series for based on the real situation for single family household usage, for town, village, and even for concentration models. We have three different series of products to meet different needs for different areas. So you can see some pictures of zero project in cross China. This is for the concentration model, and for town, village, and even for single house usage. And the last one is the sewage treatment plant. It's 30,000 tons per day in Hainan province. We built up this plant with equipment within 56 days. So that's what we think our learning and our opinions on China rural sewage treatment. Thanks all.
Thank you very much, Dr. Chen, for sharing us from an industrial perspective. And for the next 40 minutes, we are pleased to have Dr. Wenchao Xue as the moderator of the panel discussion. Dr. Xue is a director of AIT Belt and Road Research Center.
Very good afternoon, everyone. So thank you for continuing the webinar with us. So I'm very happy to continually moderating the panel discussion session for today's webinar. So for this section, in addition to our 5 distinguished keynote speakers today, we have also invited Professor Min Yang, Dr. Montip Siratana, and Dr. Peng Li to join our panel discussion. So before our discussion, please allow me to give a brief introduction of our 3 more panelists. Professor Min Yang is the Deputy Director of Research Center for Eco-Environmental Science, Chinese Academy of Sciences, and also the Director of National Engineering Research Center of Industrial Wastewater, Detoxification, and Resource Recovery. He has been working on the identification and the control of hazards in water, and also made breakthroughs in drinking water, odorant identification, on-site control of MIB, producing cyanobacteria, blockage of antibiotic resistance in environment, and so on. He has published over 250 papers in international journals and supported many engineering projects and standard setting. He helped to create the Sino Sri Lanka Joint Center for Water Technology Research and Demonstration in 2015. And he also won the second prize of National Nature Science Award in 2017. The TWAS regional prize in 2018, and the Science, Diplomacy, and Outstanding Achievement Award of Chinese Academy of Science in 2021. Dr. Montip Siratana is the Senior Advisor of the National Research Council of Thailand. She received her bachelor degree in chemistry from Mahidol University, master in environmental technology and management from AIT, and her PhD in urban engineering from the University of Tokyo, Japan. So during her tenure in the government, she held key positions at the Ministry of Natural Resources and Environment, including Director General of the Department of Environmental Quality Promotion, Director General of the Department of Pollution Control, and Deputy Permanent Secretary, as well as the Principal Inspector General of the Ministry of Natural Resources and Environment. She has also initiated the establishment of the Environmental Research and Training Center in Thailand. Last but not the least, Dr. Peng Li is the Vice Manager of Engineering and Technology Center in China Water Environment Group. He has worked for technology research and engineering applications for over 10 years, and he was in charge of nearly 10 academic research projects, such as the major science and technology program for water pollution control and treatment, and also industry projects, design, construction, and operation. There are many project examples, including the BRRC underground wastewater treatment plant in China, and also the Guiyang Nanming River environmental management projects. So he is trying to build a connection between academic and the industry based on his professional experience. Okay. So due to the limited time, let me start with some questions for our panelists today. So the first question for today's discussion will be, what are the major barriers that you think in advancing the academic and industrial cooperation in sustainable water, sanitation, and also water environment management in this region? So for this question, I would like to invite Professor Yang, Professor Zhongrak, and also Dr. Chen Hai to share their opinion. So may I maybe invite Professor Yang to share your opinion first with us?
Okay, thank you. So it's our great pleasure to participate in this workshop, and I have learned a lot from this afternoon's speakers, and so I didn't know much about the water pollution situation in Thailand, and through this workshop, I learned a lot and know that you have a very strong needs in many issues to control the water pollution. And so I'm very glad that we have the very common interest and in pushing the collaboration between China and Thailand, and particularly we are very interested in have the industry, the research institution, and the government cooperation on water pollution control and technology development and the implementation of very good technology and good practice. And at the same time, we are also interested in some like the standard setting and for the wastewater, for the industrial wastewater discharge, and also for some demonstration projects to we would like to have some the private sector and the government cooperation on some demonstration projects. And so I hope through this workshop we can find some common interests and for future collaboration. And so today we have invited some companies from China, and they are also very interested to develop some new business model in Thailand, and have some collaboration with Thailand companies and the Thailand government to see how we can contribute to Thailand water pollution control. So I would like to hear your suggestion and your opinion on how to promote the China-Thailand collaboration, and we are ready to contribute our power to help Thailand and establish a sound water pollution system. Thank you.
Okay, thank you very much, Professor Yang. I think you have pointed out a very important barrier at the very beginning, that we actually didn't know where is the problem. So that is a big barrier to talk about the future cooperation. And also you leave a question. I guess I think I can maybe continue leaving this question to our next panelist. Maybe Professor Junrak can also somehow answer your question with his talk. Professor Junrak?
Yes, thank you,
Please.
Professor Wen Chao. Yes, about the advancing academic and industry cooperation, I think in general, industry would like to cooperate with the academic sector. If academic sector can produce or generate innovative technology or ideas that industry can further manufacture and market the product. And of course, for the academic to generate innovative ideas, doing research, we need support, financial support. So support from international organization like Belt and Road or other organization would be very helpful. For example, like I show in my presentation, we have developed the cyclonic toilet, which work really well, compact, and can treat pollution, kill pathogens. But fortunately, we got the support from the Bill Melinda Gates Foundation. When the system technology works well, then of course the Siam Cement Group industry now come in and would like technology to be transferred. But of course, to have technology manufactured alone not enough. If the government sector, policy maker, do not come in to implement policy or enforce the policy, the regulation. Like Dr. Chayavi said, we have regulation, but if there are no enforcement, then nothing is done. And for the public policy, government agency to do something, then pressure must come from the people. That's why people awareness, education is important. If people become more aware, they will demand more. Then the politician, government sector will do something. So I think in this seminar, I think you have done very good job to promote the linkage. So linkage among academic industry, government, and international organization. I think if all of us work together, something good will happen in terms of water supply, sanitation, other thing also. Thank you.
Thank you very much, Professor Jonrak. And also, Mr. Chen, perhaps you can share us some opinion from the industrial sector aspect.
From the industrial side, the key challenge for us, I think the first one is if we have some cooperation project in Thailand, so we need some local support and cooperation partners for the daily operation. Because when the project is carried out in Thailand, we need people, we need local people for the daily operation and the management for the project. And the second, I think we face a key issue is lack of the market information, local market information from Thailand. We cannot get the real requirements, the real needs and wants for the Thailand market. So our suggestion is, can we set up build up a platform for sharing some information between academic industry and even the government side? We can get the real information, real need and wants from the real market. And the last one, I think, my suggestion is even we can sponsor some scholarship or training programs between the industry and academic, such as you can send some of your students from AIT to our company for training program for some short-term project-based project jobs, and even we can send some of our employees to Thailand to learn some information from your side. I think we can do some more real actions, more than meetings and some discussions. So from industry side, this is our suggestion. Thank you.
Thank you very much, Mr. Chen, for not only sharing your opinion on the very practical barriers, but also provide us some suggestions for future collaboration and also the resources. Okay, so actually this also linked to my next question. So after we talk about the barrier and challenge, so what kind of opportunities, resources, and also the good platform do you envision in terms of strengthening this industry, academia, collaborations in promoting the research and also technology innovation? So I believe that Mr. Chen has already shared some opinion with us, but I would like to get more ideas from our panelists. Perhaps I would like to invite Professor Wei, Professor Liu, and also Dr. Li to share more opinions on this question. May I then invite Professor Wei to start?
Question.
Yes, Professor Wei.
Okay. Okay. So I can start. Many thanks. So this is a very good question. So how to suggest the industry academic cooperation? I think based on our cooperation in Sri Lanka, I think the demonstration project. Can you hear me? Yeah. Okay.
Yes. Yes. Perfect.
Yes. Demonstration project is very important because for the academic, so it's no problem to R&D new technology, new novel technology, but for the demonstration, we need the support from the company. So this is a very good chance. So, for example, we do the demonstration in Sri Lanka. We based on Sri Lanka the key issue, safe drinking water for the CKDU area, because they need to treat, to purify the groundwater with high hardness and high fluoride. So that is no problem for we do the research in laboratory, but we need to do this to show this technology is very good for the local people. So we need to cooperate with the local government, local partner, and also the Chinese company. This is a very, very good thing. So the key issue is first from, for example, if we can find the key issue from Thailand, like the sanitation and the wastewater, municipal wastewater, domestic wastewater. So if we can find in the key area or key watershed, so we can do some of the demonstration project. That is be a good way to link the industry academic cooperation. That is my experience, and also, and now because there's a lot of the exchange ideas through the webinar, so now it's easy for us to get the information of the key issue. For example, this event is a very good opportunity for us to understand the key issue from Thailand, like the sanitation and the wastewater treatment. So that is really good. So I think that is really good. For example, this year we get a project from the Asia Cooperation Project program. This is for the SDG 6. So there are 3 countries, Thailand and Myanmar. So for the Myanmar, we focus on the safe drinking water. And for the Thailand, we focus on the sanitation. So we cooperate with the AIT and Professor Tamarata and also He, Mr. Chen Hai. So that is our idea. This is we already do that. We hope we can finish this project in next year. So and maybe so based on this project, we can get more information and more the opportunity. Just like the Dr. Aidan Wong said. So and now IIT will have a new global sanitation center, water and sanitation center. So if possible, so we also would like to work close together with AIT and you to do something together. And industry academia. So key issue, that is very important. And the demonstration is a very good way. So that is my idea. Thanks.
Thank you very much, Professor Wei, for emphasizing the important role of demonstration and collaboration project. So we also hope that we can build more project and demonstration in collaboration with between Thailand and China. So may I also invite Professor Liu to share some opinion on this? Maybe you can focus on the drinking water aspect or drinking water problems. Yes, please.
Thank you. I think from my side, probably I can refer to one of the previous comments from Professor Chayavi. I think it's not about drinking water; it's about wastewater. I think in his presentation he mentioned that some of the wastewater treatment plants, even after construction, the people will have different idea and they don't agree that the wastewater treatment plant is constructed at the spot. And then it's a problem for the wastewater treatment plant to continue the operation. I think in this case, this is a very critical link between the technology, the innovation, and the market to realize and to construct it. So for this case, I see Dr. Peng Li is also presenting in the workshop. The company of Dr. Peng Li is specialized in the underground wastewater treatment plant. So in this case, this can be innovation and a solution, so that the treatment plant is underground and the air and water is purified. So the neighborhood is not going to feel anything. And this is helping to solve the practical problem and also improving the quality of the environment. And this is also connected to my second point, so where the innovation and the industry can be well connected. I think there are more and more research departments in different organizations. So we are doing research in research institute, and we are researchers, but we sometimes looking into more fundamental problem and fundamental question that has a big distance to the practice. Well, the popping up the presence of research department in, let's say, governmental organization and also the industry companies is connecting very well. So the researchers can talk to the researchers in the organization and company, and then they can find a solution to a question between the fundamental and practical questions. And then this is bridging the innovation and the market. I think it doesn't matter about drinking water or wastewater. This is going to solve the problem more smoothly with the cooperation between researchers in the institute and researchers in the company. And I think that the third one will be pinpoint, so pick out the very critical and limiting factor, and then to see the need of the drinking water sector and wastewater sector. And this is going to generate technology, equipment to solve the problem. I think those are my opinion. That's all. Thank you.
Thank you very much, Professor Liu. And I'm very impressed that you mentioned the important role of researchers in company, which means R&D. It's very important to do the R&D in the private sector. And for this point, I think probably Dr. Li can give us more insight on the role of researchers in industry, and how can you play an important role to connect the research institute and also the private sector in order to link this collaboration. Yeah, Dr. Li, please.
Okay, thank you, everyone. Can you hear me?
Yes.
Okay. Thanks for Professor Liu says that our company, I'll give a short introduction about my company. The company's name is China Water Environment Group, and we focused on the urban and the rural sewage treatment, as well as river and lake environment management. Professor Liu introduced that we choose the underground wastewater treatment plant as our main project. Why we choose that is that that's all come from the real engineering problems. Our company started in 2017, and in less than 10 years, now we are the the biggest company in China for the underground wastewater treatment plants. We build wastewater treatment facilities underground, and on the ground we can do the landscape, or maybe for the industry development. It solves the not in my backyard problems, and also it can save a lot of money, because you don't need you need less land, and you need you don't need the new construction of sewer, and you can reuse the water with short distance. And furthermore, we can find out many resources in the wastewater treatment plant. You know, you can see we can get the natural gas from sludge. We can get heat from the water, and maybe in the future, I think we can get the nitrogen, phosphorus, or maybe other organic matters. So if we don't treat the wastewater as a pollutant, we treat it as a resource, and we don't treat the wastewater. We make the goods from the wastewater. We make the products. So if we build our plant near the city, in the city, near the users, near the citizens, and we also supply the products near them, and then we can reduce our cost for the transport. So we think that the underground wastewater treatment plant is a promising way to solve the problems for the environment for the development and for the land, maybe, and also for the investments. So, in my opinion, that we developed our technologies during the engineering problems, during our engineering applications. But before we find, when we face the problems, we have to find the way to solve it. We have to connect with the institutes, with the universities. But now, I think today I know many problems from the Thailand, and I think it's same as we faced before, 10 years before. And we now find the solutions, but we also need some more technology innovations. I think we can cooperate together. We can have our we can share our experience, and the institute and the universities can do more technology innovations, and together we can find the solutions for the environment problems in Thailand. That's what I want to say. Thank you.
Thank you very much, Dr. Lee. Okay, so now we hear about the opinions and suggestions from both academia and also industry side. And then the next question, perhaps we would like to ask about our governmental side. Okay, so the question is what could be the policy implication and also strategies in research innovation and the practices for a better SDG implementation through more active regional collaboration. So this question, I would like to invite Dr. Montip and also Dr. Chayavi to share a little bit of their opinion. May I maybe firstly call Dr. Montip? Yeah, Dr. Montip, please unmute your speaker.
Maybe it's mute. The voice cannot be heard.
Okay. Dr. Montip, please. Dr. Montip, please, could you please try to unmute again?
Again? Can you hear?
Yes, we can hear you. Yes,
okay.
Please.
Okay, thank you. So my questions related to policy implications and strategies in research, innovation, and practice for the better SDG 6. Well, I like to recall a little bit more about SDG 6. SDG 6 is to ensure sustainability and sustainable management of water and sanitation for all. So there are 8 targets, as Dr. Jolak has mentioned, like, for example, achieve universal and equitable access to safe and affordable drinking water for all, achieve access to equitable sanitation and hygiene, improve water quality, substantially increase water use efficiency across all sectors, implement integrated water resource management, protect and restore water-related ecosystems, and expand international cooperation and capacity building, plus support and strengthen the participation of local communities that we have been discussed, and improving water and sanitation management. So I would like to mention about the strengths of the Thailand's water security. The strength is we have high clean water accessibility, about 98% compared with the rest of the world. Population has access to improved sanitation facilities, about 96%, and 25% of agricultural area irrigated, comparing with global average of 19%. And freshwater agricultural area that we have now is about 3,700 over square kilometers. But the weakness of our water security is related to low runoff per capita per yearly, and also high proportion of agricultural water use and high water footprint in agricultural sector. We rank about 3rd globally. The other one is development potential in Thailand, still low industrial water use compared with 37 cubic meter globally. We have 34 cubic meter per year, and low water use for energy about 4% comparing to global average 31%. So these are the Thailand's water security strength, weakness, and some potential to develop more. And there are 3 pillars of water management in Thailand. The government has led a new water management mechanism which comprise 3 pillars. The first one is legal aspect. I think we have come up with the Water Resource Act, which has been deliberated by the National Legislative Assembly, and the law has taken effect last few years. The second one is national level organizations in the water resource management. National Water Resource Committee has been established, and the chair is the Prime Minister of Thailand to act directives and key operation plan according to the national water strategy. And the National Office of Water Resources was also established to tangibly mobilize policies and directives, monitor and follow up on the operations. The last one is Water Resource Management Strategic Plan that the Cabinet has been endorsed and approved, plan of 2015 to 2026, and the guideline for the country's water management operation. So the strategic plan of water consists of 6 strategies. The first one is management of water consumption, water security for production sector. The third one is flood management. The fourth one is water quality management. The fifth one is rehabilitation of forest watersheds and degraded areas. And the last one is management and administration. So all of these policies has already been established. I want to go on implementation through active regional collaboration. I think China has made noteworthy achievements in scientific research, technological development, and promotion and commercialization of research results related to water resources. So at present, water science and technology in China are up to advanced international standard in general, with individual areas such as sedimentation, small hydropower, dam technologies, and soil and water conservation already taking the lead in the world. So another one, capacity building in water science and technology. I think based on the practical experience of water governance, the Chinese government advocates in water science technology actively applied new and high technologies to reform traditional water management. And the last one is I'd like to introduce promoting of overseas water technologies. I think technologies, devices, and facilities that match the characteristic of water sector for many countries should be looked at, like allocation of water resources, disaster preparedness and reduction, rural water conservancy, water and social conservation, monitoring of water environments, and ecological governance. So for the challenge, I think there are still conflict between socio-economic development and the carrying capacity of water resources, and the water environment keep intensifying. So further proceeding of industrialization and urbanization and increased global climate change exposed, I think these are also more severe problems in the future. So innovation in water science technologies in line with new requirements of socio-economic development should be included. So greater importance that I would like to propose research on the impacts of global climate change and large-scale human activities on water resources. Second one, research on the strategies and countermeasures to solve problems such as drought and water shortage, flood, water pollution, and soil erosion. The third one, integration and combination of engineering, technology, natural science, and social science in water work. The fourth one is promotion, commercialization, and application of research results in water science and technology. And the last one, application of new and high technologies in the water sector. I think those are the things that I think we should look at the regional cooperation. Thank you.
Thank you very much, Dr. Montip, for sharing your suggestions from global, even regional scope. So maybe may I next invite Dr. Chayavit to share perhaps more from the practicing aspect, or you are the governor working on the first line. So please also share us some opinion and suggestions. How should the government sectors help with this collaboration? Dr. Chayavit, please.
Yes, I think maybe the most important thing about when we are talking about research is that what is the good topic, right? From people who experiencing the problem, that if the good topic, if the topic of the research is required research or not, or we actually take we can take like solution from other country, like other speaker can say that some of the time this kind of problem is not require research anymore. It's already solved in other country, but we just not aware of the solution that other country has been doing. For innovation, I think there's a lot of innovation that we are trying to take to solve the problem in Thailand. But my experience is that it's better to involve the local government into the project, or the worker who is actually on the field to be in the project before deploying innovation. Because the tricky thing is that a good solution for researcher or innovation is not always be a good one for the operator or the people who is actually on the field. They sometimes reject a very high technology. My experience is that sometimes we install like SCADA system for the local government, invest for million, like hundred of million of the dollars of the million baht, and see that a couple of years later is actually disintegrated and no one is actually operating it, and with low maintenance from the local government. So maybe experience that I learned is that maybe the most problem that we are having, especially in Thailand, is not actually really different from other countries. We actually have like some of the seminars in wastewater management amongst other Asian countries, and found that actually most of the problem is very similar. Maybe because of our living configuration is very similar. Probably is very similar to China. So maybe maybe we can actually compare all the problem that we have and see if there's anything that's really common in many of the country, and we can set that such a common problem as a priority among us, and then we can set up, probably the strategy should be like set up the work group of the people who actually on the field and compare such problem and see if any problem come up as a priority problem that we should solve the first. For Thailand, I actually can do that inside Thailand, and I actually found that like money is the problem, but actually money is a common problem among not only environmental topic but also other topic, but probably we environmental problems get a very less priority when it comes to money. So we actually identify that as the first priority. How can we get money more for environmental problem? Another thing that I would suggest is that I think it would be nice if we can set up like official cooperation program between among ASEAN country and China, specifically on SDG, so that we can officially identify a common problem among country and probably set up a research topic that is actually will be valuable for our country. And that if we think that it actually a good research topic, we can work together. And if such a problem that we identify require change in regulation or innovation or solution from other country, maybe we can do that, and we can have like a steering committee on such like a official cooperation program where we can come up and come together and prioritize research topic. And probably I think majority of when we talk about research, I think the most important thing is the funding for research. And I think that even though that because I'm in the like department, which our department is not actually focusing on the research, but I think that my organization can, if the problem is really important, we can actually pay for partially for the funding for the project, especially if we need to collect the sampling or doing survey or something like that. We can also contribute something if the topic is really nice and suitable for doing the research. So probably that is my strategy. Probably we should like compare common problem and set up a good research topic among us, I think. Thank you.
Thank you again, Dr. Chayavi, for sharing your opinion and also even generously offer some research fundings to support this water sector research and innovation. So I think I would like to appreciate all the speakers and panelists again for sharing your experience based on different countries and also your professional opinions, say from different sectors. So it's a very informative and interesting for all of our people working in this field, and also I believe for our audience too. So I think I'm going to close this panel discussion. Then we will invite Professor Min Yang and Dr. Montip to provide a quick wrap up and closing for our today's webinar. Thank you very much.
Dr. Xie, and so it's a very nice and very fruitful discussion today. And as you know, China has accumulated very fresh experiences in coping with the water pollution challenges. We have now established a well-developed urban wastewater management and treatment system, and we have also established a relatively sound and effective industrial wastewater treatment and management system. And now we are making our efforts in establishing the rural wastewater treatment system. And so I think we have many fresh memories and experiences to share with our Thailand colleagues and friends. And so we will be very happy to share these experiences and memories with our Thailand friends. So I suggest that we can cooperate with the AIT to do something. For example, we can join the sponsor some training programs both in Thailand and in China. We can organize some industrial workshop to promote the collaboration of the industry between the two countries. And so I think we need to the industry people to become friends, and so the industry people from the two countries should become friends, and then we can start our cooperation, and then we can also think about to sponsor one or two treatment demonstration projects, and so for details, and I think Professor Wei will discuss with our friends in AIT to identify the suitable for this kind of demonstration project. And except for this kind of industrial collaboration, I think we also need to enhance our research collaboration. And so for student education, for researchers collaboration, and so we need to do some joint research to cope with the future challenges. And so I just suggest that maybe we can think about to establish some joint research program between the Thailand Science Technology Development Agency and the China Nature Science Foundation. And I don't know if these two agencies have already established some formal relationship or not. If not, I strongly suggest you can have some to sign some agreement, and then maybe you can jointly sponsor some research project focusing on water-related issues and other scientific issues. And then maybe we can also think about to have some researcher and student exchanges, and also we can have some joint PhD programs. And so I think there are many opportunities to for us to promote the collaboration, and we are ready to do our best to promote this kind of collaboration. And thank you, and thank you very much. That's all.
Thank you very much for Professor Yang. Now we're pleased to have Dr. Montip Saratana to give the closing remarks.
So thank you very much. It has been a productive seminar the whole afternoon. We have had interesting presentations and panel discussions on the issues of strengthening collaboration and networking between Thailand and China by building linkages among academia, industry, and government. Researchers, practitioners, and policies makers must work together on the issues of clean water and sanitation in particular, let alone the entire Sustainable Development Goals, which has been a pressing problem not only in the region, but throughout the world at large. Look at the problem of COVID-19, of course, impacted the people, the environment, economy, and the pandemic presents impact on the SDGs. And so the latest, if you look at the UN SCAP report for 2022 says that progress toward the SDGs in the Asia and the Pacific has slowed as the COVID-19 pandemic and climate change have exacerbated development challenges. And the region is not on track to achieve any of the 17 SDGs, including SDG 6, in which we have to try our best to make it progress. So we must exert all efforts to alter trajectory toward achieving the SDG targets by 2030, particularly on SDG 6, clean water and sanitation, which is critical for human survival. So I hope more dialogue like this kind among stakeholders from these three sectors, namely academia, industry, and government, be organized in the months and years ahead. So I so much thank you for your kind participation, and I wish you success and stay safe. Thank you very much for your kind participation. Looking forward to collaborate again in the near future. Thank you.
Thank you very much, Dr. Satana. Now, ladies and gentlemen, we have reached at the end of our webinar today. First and foremost, I would like to express my appreciation to all those speakers today for sharing their expertise and valuable contribution. My deepest gratitude goes to all participants of our webinar, our sponsor and staff who provide valuable support to make this webinar successful. We have now in-depth discussion on the issue of SDG 6 through government, industry, and academia linkage. Please continue to support the Belt and Road Research Center series and other events as always. We will keep you informed on our upcoming activities. Looking forward to seeing you next time. Have a nice day. Goodbye.